All right, Lines on Clay viewers, there is this sheet here that you can go in and toggle around. It's called X and Y as z-scores. We certainly invite you to do so. We've already looked at this connection between these three data series. X, which is a set of data that I made up. Y, which is just a linear expression of X. It's a perfect linear expression. And then Y minus a wiggle term, where we have this wiggle factor, and it's going to be between 0 and whatever number I put in there. So between 0 and 40 or 0 and 10 or 0 and 2, you name it. That is going to cause a random set of values that related to this second series Y. Now, what we didn't do last time that we are doing this time is we've converted all of our raw data values into z-scores. Remember, we can take any series of data that we want and we can reconstitute it. We can restate each and every value as the number of standard deviations away from the mean that particular data point lives. So in other words, 3.1 lives 0.13 standard deviations below the mean for X, whereas our raw data set, say, has a mean of 3.32 and a standard deviation of 1.6 for X. Here, the standardized data, the means are all 0 and the standard deviations are all 1. Let's take a look and see what happens when we are thinking not in terms of the raw data, but in terms of the underlying z-scores. And here, we get absolute lockstep one-for-one connection between X and Y. I should say X's z-scores and Y's z-scores, because remember, this is the raw data for X. All the values for X live between 0 and roughly 7, and just based on what I've put in here, all the values for Y live somewhere between like 10 and roughly 40. But their z-scores line up absolutely perfectly. On the other hand, when I add in a wiggle factor, then the z-scores no longer match, right? Like they're not far from each other, but they don't match. And the more I make the wiggle factor, the less they match. Well, here are the z-scores now. They're a little farther off from one another. So let's go, kind of crazy here. Now the z-scores really don't match. And what we find is that the correlation coefficient is effectively looking and analyzing how did the z-scores match, how well did they match in comparison to how well could they have matched. And so in this sense, a correlation coefficient is nothing more than a z-score matchmaking service.